Good afternoon, students. How are you? Welcome to one more fabulous session from Infinity Learn by Sri Chaitanya. I am Suresh, Faculty of Chemistry. Hello, how are you? Rajesh, hello. Kitawat Rajesh. I think you are present in the previous sessions and a couple of sessions you are not there in middle, right? Yes. How are you, beta? Okay, if you are available, you just attend the sessions. If you are not available, you just watch the replay of the sessions and you can ask any kind of doubts in this comment box. I am going to reply it. Right, Rajesh? That's good. And I am Suresh, Faculty of Chemistry from Infinity Learn by Sri Chaitanya, and this is your YouTube platform and NEET STEP UP 2025 program. Here we are providing physics, chemistry and biology classes right from 12 o'clock to evening 6 o'clock. So total NEET syllabus is going to be covered for the free of cost for you guys on YouTube channel. So Infinity Learn NEET channel, you please subscribe it and daily you attend these sessions. If you are not able to attend these sessions, you please watch the recording so that you can like and share and subscribe it. So total syllabus you are going to cover, and we are the expert faculties from the NEET and we are providing the total syllabus at the level of NEET. So if you follow these sessions without any fail, you will be getting a very good score in NEET 2025. Mind it. So it is a promise given from us by Infinity Learn. So please be regular and do work sincerely according to the teachers are given. Okay, Ishita, hello. Who is that unknown? I'm okay. Let's go. Good afternoon. Okay, who is that unknown? Yes, let's start. स्कूल की वजह से लाइव क्लासेस नहीं कर पाए, इसलिए आई एम टेलिंग you please attend if it is possible. Okay, नाम भूल गया, Abhinav or kind of name, right? Okay, right. If you are not able to attend, watch the recording. That's very important, right? Very good. So फिर से भूल गए मैं, सर unknown हर दिन 5 बच्चे 4 बच्चे आ रहे हैं ना, so how do I memorize all the names, right? So Abhinav, I told na, Abhinav, right, that's good. Okay, coming to the topic over here, today's topic of interest is aromatic hydrocarbons. We are discussing a part of physical chemistry and a part of organic chemistry. In this particular week, we had 4 organic classes. Here, yesterday we started about smell of aromatic compounds. So, aromaticity, conditions. So, aromatic, non-aromatic and anti-aromatic we discussed in yesterday's class, right? So, what are the conditions to say a compound to be aromatic? So, short recapture before we start today's class, aromatic hydrocarbons. So, yesterday we were talking about aromaticity. If you want to say a compound to be aromatic, it should fulfill 4 conditions. It should be cyclic, planar, complete conjugation throughout the ring, and Huckel rule should be followed. If a compound has these 4 points and accepted, it is an aromatic compound, right? Yes. Yes, very good. Yes, very good. If you want me to recall, I can recall it, right? So, anyways, I am going to recall what you are going to learn. So, I'll come back here. So, as one of the student is still struggling to identify the aromaticity and all, I just go back and I'll come to the first slide again. So, conditions for the aromaticity, a short recapture of the yesterday's class, right? Conditions for the aromaticity. As per the request given by the students, I just want to give a shortcut trick so that it is going to be recapture and a trick in your mind. So there are 4 points beta. So what are these 4 points? The compound should be cyclic and it should be planar in its structure, and also complete conjugation should be there in the ring. I just want to say complete resonance in the ring. So if you say resonance throughout the ring, it should be there, right? And one more, it should follow Huckel rule, Ishita. And you tell me what is Huckel rule, Ishita? 4n plus 2 number of pi electrons. 4n plus 2 number of pi electrons. So these are the 4 conditions. These are the 4 conditions. Now I just want to say, ad hoc slide, right? So cyclic, complete conjugation, and Huckel rule. Very good. And if you say here, if you want to say a compound to be aromatic, non-aromatic, and anti-aromatic, there are 3 things: aromatic, non-aromatic, or anti-aromatic. So non-aromatic. There are the 3 types of compounds. If a compound, if we want to say aromatic, it should fulfill first point, second point, third point, fourth point. That's it. So if a compound fulfill all these 4 points, you can say a compound is aromatic. If this compound follows all points but it do not follow only Huckel rule, you can say it is anti-aromatic. Okay. And of course, if any one of the 3 points is not followed, any one of the 3 points is not followed, okay, so there is no sense of looking at the 4th point, that you can say it is non-aromatic. Simple trick you can keep in your mind so that you will understand everything, my dear students. So the lesson I am giving is very important. Stay tuned. Okay, just simply joining and leaving the session doesn't make sense. Okay, the valuable information I am giving you, my dear students, you just keep with your book and pen and write all these things so that you can get the very valuable, very information you are going to take. So among aromatic and anti-aromatic and non-aromatic, so what are the things we can extract it? Aromatic compounds are super stable, awesome, and anti-aromatic compound is highly unstable. ये 4th point का वजह से ये compound पूरा की पूरा anti-aromatic बन गया. So order of stability, so aromatic is more stable than non-aromatic, is more stable than anti-aromatic. So based on this, you can crack a question in the NEET examination. Which of the following is highly stable? Give the order of stability. Which of the following is least stable? Kind of questions will come. Aromatic is more stable than, non-aromatic is more stable than anti-aromatic. Are you getting or not? Clear? Fine. So this is the recapture that happened in yesterday's class. In yesterday's class, we talked about aromatic compounds, benzenoid aromatic compounds, non-benzenoid aromatic compounds, and their structures, and everything we discussed extensively. So if you want to re-watch it, and you go to the recording and you can re-watch it, that is available on the NEET channel. Ishita, right. So let's go ahead again with the first slide. So what you learn in today's class? Today's class is pretty important here, right? You will learn today about introduction to the structure of benzene, that we already did it, and a short recap again we will do it, and preparation of benzene and electrophilic aromatic substitution, a बढ़िया important है, that is very important. Okay, so this particular thing is utmost important. If you are okay, you are going to do 50% of the organic chemistry in your hand. Okay, organic chemistry handle करना बहुत आसानी काम है. My dear students, let's go with direct influence of mono substituted benzene. यहाँ से आपका नीट एग्जामिनेशन का सीधा क्वेश्चंस आपका निकल जाएगा. Okay, so let us see the structure of benzene. Oh, let's see the preparation of benzene. Okay, after preparation of benzene, we will look into the structure of benzene. Benzene is prepared from alkanes. So N-hexane, you can see CH3, CH2, CH2 and CH2 and CH2 and CH3. This is N-hexane. So 6 carbons are there. In the presence of Cr2O3 and Al2O3, okay, if you heat it, this linear N-hexane is going to make a cyclic structure like this, CH2 and CH2 and dehydrogenate करना है, so that you are going to get C6H14. बाद में ये dehydrogenase करके आपका मिलेगा benzene. So this method is actually used in the industries, petrochemical industries. Avatar Thakur, ha, how do you know me? Avatar Thakur, how do you know me? Have you ever attended my previous classes or any live classes or classroom classes? Avatar Thakur? I don't remember actually, because I teach for thousands of students in a year, that's why. Okay, this is about the preparation of benzene from hydrocarbons or from alkanes. Okay, yeah, where do you find me, Avatar? Where do you find me? Right. So here from alkyne also, cyclic polymerization of alkyne, ethyne, this is ethyne, means it is, you can say C2H2, this is ethyne or acetylene, ठीक है? Yes, it is passed through red hot copper tube. So in that red hot copper tube, if acetylene is passed, so it is going to be C6H6. This is a cyclic polymerization reaction. So this cyclic polymerization reaction, you can use red hot iron tube or you can use red hot copper tube, doesn't matter, right? You can see if, और एक example भी discuss कर सकते हैं इसका, propine. If it is a propine, C triple bond CH, it is a propine. If undergo red hot copper tube, so what is the product that can be formed? So Avatar Thakur, you said that you know me, but you didn't say how do you know me. Okay, so this is going to form again a cyclic compound like this, but every 2 carbon atom contain a methyl group, so that there is an alternative methyl groups like this. So what do you call this is? What do you call this is? Mesitylene. This is called mesitylene. Got it? So very important point, clear, fine, that's good. Write down. Any doubt? Any doubt? Abhinav, any doubt? Ishita, any doubt? I am 3N. What's your name actually? I am 3N. What's your name? So that I can call you with your sweet name. That's good, fine. Any doubt, Ishita? Okay. Let's talk about one more preparation method. One more preparation method here. Where is that Josh? Okay, preparation of benzene from phenolic compound. What happened when phenol, this is your phenol, benzene with OH group is called phenol, right? No doubt, very good. If it is heated with zinc, what happens? Zinc is a very good reducing agent, so that it love oxygen, so that zinc oxide is going to be formed. So what happened? Benzene is the product here. Benzene is the product. You understand? Clear? So like that you have to see. So this is a phenol reacted with benzene, zinc gives rise benzene. So this is para-methyl phenol. When you heat it, you are going to get, what is the name of the molecule? Toluene. Right? Okay. Yes. Very good. Now let us see the decarboxylation reaction also we can see. Okay. So from carboxylic acids, when benzene carboxylic acid is heated, okay, this is benzoic acid. Benzoic acid. This benzoic acid, when heated with soda lime, so carbon dioxide is going to be removed, so that what happens here? CO2 is removed, so that benzene is the product. So we are talking about the preparation of benzene. Hope you are all understanding the best methods. Similarly, this, what is the name of the molecule beta? This is called salicylic acid. This is salicylic acid. This salicylic acid is heated with again soda lime, so CO2 is going to be eliminated, so that you are going to get toluene. So this kind of question, simply what happened when salicylic acid is treated with soda lime, the product is A, B, C, D options. नीट में अच्छा तरफ क्वेश्चंस पूछना का संभावना है. सो आप देखना, सो हर एग्जाम्पल अभी इसी वक्त में हम डिस्कस कर रहे हैं, ये नीट एग्जामिनेशन का फिल्टर करके दिया. सो आगे नीट एग्जामिनेशन पे आना के चांस ज्यादा भी ज्यादा है. ओके, दैट प्रिपरेशन ऑफ बेंजीन फिर भी ग्रिग्नार्ड रिएजेंट से प्रिपेयर कर सकते हैं. ग्रिग्नार्ड रिएजेंट हम आप पढ़ाए थे जब अल्केन का में. ग्रिग्नार्ड रिएजेंट फिनाइल मैग्नीशियम क्लोराइड, दिस इज ग्रिग्नार्ड रिएजेंट. Okay, this phenyl magnesium chloride is a very good nucleophile and a base, so that this H, this is going to take H plus and OH minus, so that you are going to get benzene. Phenyl magnesium chloride, when hydrolysis, it can be hydrolyzed with anything. By what are the things can be used for the hydrolysis, you tell me? You can use any H प्लस आयन डोनर, लाइक आप H2O इस्तेमाल कर सकते हैं, आप मिथाइल अल्कोहल इस्तेमाल कर सकते हैं. ओके, आप फिर भी फिनॉल इस्तेमाल कर सकते हैं. ओके, और एसिटिक एसिड इस्तेमाल कर सकते हैं, CH3COOH. यानी अमोनिया भी इस्तेमाल कर सकते हैं, अमाइन, प्राइमरी अमाइन भी इस्तेमाल कर सकते हैं. यानी कंपाउंड दैट कैन गिव H प्लस आयन कैन बी डिलिबरेटली यूज्ड हियर. Are you getting or not? So preparation of benzene इतना खास बात नहीं कि it is very simple. Okay, and from sulfonic acid, this is what you call it as benzene sulfonic acid. This benzene sulfonic acid is passed through the superheated steam and followed by hydrolysis in the presence of an acid. So it is going to give benzene. So benzene sulfonic acid can be heated, okay, and can be reversed to the benzene. So we will discuss about the sulfonation. So this is not actually one of the method, but in this method we don't prepare benzene, but this method can be used for preparation of other aromatic compounds. So sulfonic acids are very important. Okay, talking about, so let's talk about the reactions of benzene. So what is the reactions of benzene? So reactions of benzene बोलने के लिए आपका पहला बेंजीन का स्ट्रक्चर पता होना चाहिए. So benzene, if you talk about the benzene, this is your benzene. When it is treated with KMnO4 in the presence of alkaline media, what is happening here? It's a Bayer's reagent, right? Bayer's reagent is extensively used for testing unsaturation, but here the Bayer's reagent, however the benzene has 3 double bonds in it, it is not at all reacting. Benzene, however it has 3 double bonds in it, it is not behaving like an alkene. This is an interesting topic. Why it is doing like that? Because of the benzene is in resonance, the pi electron system is in resonance, it is delocalized, therefore it do not undergo addition reaction. So a perfect notes is given to you all guys. You can download these notes in the Telegram channel that we are going to give you, right? So if you add chlorine in the presence of light, okay, or bromine in the presence of light, no reaction. Okay, you can say CCl4, okay, no reaction, but it is undergoing substitution reaction. Chlorine in the presence of AlCl3, it is going to give you plus HCl. Yes, one hydrogen is being substituted with one chlorine. So due to delocalization, due to aromaticity, due to this delocalized pi electron system, the benzene above and below the ring, the benzene do not undergo addition reaction, rather it is undergoing substitution reaction. Is very important point. The statements that I used is directly asked as a statement 1 and statement 2 type of questions in NEET examination. So when you write, already you have written 2024 NEET examination, you have some idea question kaise पूछा जाएगा. So you have assertion reasoning kind of question, you have statement 1, statement 2 type of question, you have multiple choice questions, right? In that, benzene do not undergo addition reaction, but it undergo substitution reaction. These are the statements. The reason, due to delocalization of the benzene, pi electron cloud above and below the plane of hexagon. So the pi bond is not available for addition reaction, rather it participates in substitution reaction. So that you need to have a kind of analytical mind, so that a statement we given, a statement 2 is given, fact everything is in front of you only, but you only have to address which is correct, which is not correct, whether that other statement is explaining the first statement. That lies the secret behind the cracking NEET examination, my dear students, right? So let's see quickly this structure of benzenes. हर कार्बन बेंजीन में sp2 कार्बन में, so every carbon undergo sp2 hybridization so that they form sigma bonds. Here sigma bond with hydrogen, sigma bond with hydrogen, sigma bond with hydrogen, like this, sigma bonds with hydrogen. Now जो pi bond है ना, so the p orbital sp2 means एक p orbital they are available, so that these p orbitals are going to laterally overlap to give rise, this is called pi overlapping, so that the pi bond is appearing like this. There is a pi bond, so that the pi bond is appearing like this. There is a pi bond, so that pi bond is appearing like that. Benzene has the total पूरा के पूरा plane का structure है बेटा, right? So if you see the bond is expected between these two, फिर भी ये दोनों का बीच में होगा ना, therefore ये pi bond is expected here. There is a pi bond that is expected there. There is a pi bond that is expected there. Are you getting or not? So that it is given like this. There is you can see there is a pi electron system. This is the benzene hexagon structure. In that benzene hexagon structure, you can see on the plane of the hexagon ऊपर एक साइक्लिक स्ट्रक्चर है पाई इलेक्ट्रॉन का, फिर भी नीचे और एक साइक्लिक स्ट्रक्चर है. अंडरस्टैंड? This cyclic structure of the pi electron is not ready for addition. So that what happened here, you can see जो हाइड्रोजन है ना यहाँ पर, ये हाइड्रोजन सब्स्टिट्यूट करने का कोशिश करता है. That is what is happened. So I want to say benzene participate in substitution reaction but not in addition reaction. So the 6 pi electrons thus delocalized can move freely above and below the hexagon. Therefore, if electrophile want to come and add, there is no pi bond is free, so that they are busy. So that what happen? Electrophile cannot add. So electrophile क्या कर सकते हैं? पीछे जाके हाइड्रोजन पकड़ के सब्स्टिट्यूट कर सकते हैं. So benzene undergoes substitution reaction but not addition reaction. So what this electrophilic aromatic substitution reactions of benzene. So this is the major discussion for today's class. Very important, very important. If you see the total organic chemistry, you have aromatic and non-aromatic, alicyclic and open chain, right? So cyclic structures, you have aromatic, in that major compounds are aromatic compounds. There you have electrophilic aromatic substitution reactions of benzene. So let us take most important reactions of benzene are electrophilic substitution reactions. These are all denoted by Se. So substitution electrophilic reaction. What is electrophile? This is electrophile. This is electrophile. Electrophile is a species which love electron. Okay, so this may be a positively charged. Okay, fine. You can see here, my dear students, you kept quiet. Why? Talk to me something. So what happened? Benzene has 6 hydrogens. Here one hydrogen, here one hydrogen, hydrogen, right? For our convenience sake, I just want to show one hydrogen here, right? So this electrophile is going to occupy the place over here, and this hydrogen is kicked off. So this is an electrophile is substituting. So this is an electrophilic substitution reaction. Okay. So we have various kinds of electrophilic substitution reaction. जो electrophilic substitution reactions का ये mechanism भी important है. ये sigma complex form हो रहा है. I am going to explain everything. Ishita, are you there in the class? No, nobody is charting in the class. What happened? Any chart click in the class? Just a minute. Is there any chart glitch in the class? Dear students, please reply in the chat box. Okay. So you all kept quiet. Why? So keep asking doubts, dear. This is not a radio transmission class. This is a live session. So there should be an interaction between you and me, right? Okay. Let's see. So you have electrophilic aromatic substitution. In that, one hydrogen of the benzene is replaced by some electrophile. I am going to tell you what is that electrophile, and it gives an electrophile is replacing the hydrogen. Replacing reactions are called substitution reactions. Let's see, you have various methods. Step 1, you see there are many steps. Step 1, this electrophile, is that visible beta? This is electrophile. This electrophile is occupied by the pi electron system, so that the electrophile here, I just want to keep one hydrogen for your convenience sake. Okay, here, or here, right? Okay, let me give you here one hydrogen, right? So that the electrophile is going to be added. So a pi bond is converted into a sigma bond. Mind it, here यहाँ पर एक pi bond था, ये नया sigma bond बना दिया, right? Yes, it is. Okay, now this is going to be further stabilized by resonance. So it is what you call it as the intermediate sigma complex. It is called sigma complex. Now this sigma complex formation is the first step in this electrophilic aromatic substitution, and the second step में अभी तो second step में anything which can abstract the H, so that H plus is going to be removed, and this Y mean to electrophile is going to be completely replaced. This is going to be the product. Based on this mechanism, so what is this? This is your electrophile. हर substitution reaction में electrophile क्या होगा? A, B, C, D options in the NEET examination. यहाँ पर एक क्वेश्चन एक्सपेक्ट कर सकते हैं आप लोग. एंड ये रेट ऑफ रिएक्शन, ये पूरा मैकेनिज्म में इंटरमीडिएट कौन होगा? सिग्मा कॉम्प्लेक्स इज द इंटरमीडिएट. सेकंड क्वेश्चन. एंड द थर्ड क्वेश्चन, ओके, सो व्हाई दिस पाई इलेक्ट्रॉन सिस्टम? सो द प्रोडक्ट, कौन सा प्रोडक्ट फॉर्म होगा? सो यू हैव 5 golden reactions for the benzene substitution reaction by electrophilic. What is that? So the 5 most common electrophilic golden reactions, electrophilic aromatic reactions. First one is halogenation. A bromine or a chlorine or a iodine substitute for one hydrogen on the benzene, right? So that reaction is called halogenation. If it is a chlorination, bromination, iodination, बट फ्लोरिनेशन ऐसे आप नहीं कर सकते. ओके, दूसरा क्या है? नाइट्रेशन. ये नाइट्रेशन में ये नाइट्रोनियम ग्रुप NO2 group is substitutes for the hydrogen of the benzene. And the third one is sulfonation. In the sulfonation means sulfonic group, SO3H group is substitute for the hydrogen. And the fourth one is Friedel-Crafts alkylation, and the fifth one is Friedel-Crafts acylation. So acylation, acylinium ion, so acyl group is going to be substituted. Alkylation, alkyl group is going to be substituted. Like that, only five reactions are there, beta. So are you all understood till now? Any doubt, please put in the chat box. Okay, Abhinav, come on. Who is that? Thakur, any doubt? Other students, I am looking at the chart only, come on. जल्दी जल्दी करना, फटाफट. फिलहाल कुछ डाउट है क्या? हाँ, YouTube चैनल में एक बेल बटन होगा ना, ये दबाओ एक बार. सो सब्सक्राइब मिलेगा आपको, जो भी सेशन है आपको अपडेट भी मिलेगा. Yes, and you have been given a Google form. You please fill it so that you will be getting an updates on the NEET examination, right? Okay, let's talk about the halogenation. So in that halogenation we can say bromination, chlorination, iodination. In that bromination you see, so bromination abhi to bromine hai na, so I'll give you the mechanism here. You can see bromine, a pair of electron in the presence of FeBr3 इस्तेमाल कर सकते हैं. Al, Cl3, anything you can take. If you take FeBr3, so it act as a Lewis acid. What is Lewis acid? Electron pair acceptor is called Lewis acid. So that this is a Lewis acid. लुईस एसिड क्या करता है बेटा? इलेक्ट्रॉन पेयर, इसमें इलेक्ट्रॉन पेयर है ना, ये इलेक्ट्रॉन पेयर इससे एक्सेप्ट करके सो FeBr4 मिलेगा. सो दैट यू हैव Br plus, this is your electrophile है ना, this is your electrophile. this electrophile अभी तो बेंजीन जो है, सो इसका ये सिग्मा बॉन्ड है, हमारा हाइड्रोजन जो रिप्लेस करने वाला है. सो ये Br प्लस इलेक्ट्रोफाइल का ये पाई बॉन्ड अटैक करने के बाद आपका मिलेगा ये सिग्मा कॉम्प्लेक्स आएगा I से. सो it is Br and hydrogen. Are you getting or not? So this is the mechanism, you need to be confident in it, right? So this positive charge फिर भी it is in the resonance. अभी resonance कर देना है इसका. So that इसका देखो, yes, ये सिग्मा कॉम्प्लेक्स इज खाली रेजोनेंस स्टेबलाइज्ड बेटा. ओके, जो रेजोनेंस स्टेबलाइज्ड ज़्यादा फॉर्म करने का कोशिश करता है. ओके, सो दैट यू कैन गेट इट. सो नाउ दिस सिग्मा कॉम्प्लेक्स आपका दिखा देना चाहता हूं, ये इसका रेजोनेंस हाइब्रिड है. सो रेजोनेंस यहां से यहां तक जा रहे हैं, यहां ना जा रहे हैं ना, है ना. हाँ, राइट. सो दिस इज व्हाट यू कॉल सिग्मा कॉम्प्लेक्स. दिस इज व्हाट यू से इट इज ए सिग्मा कॉम्प्लेक्स. वह ये निकालने के बाद आपका निकलेगा H प्लस, सो दैट you would get bromobenzene like this. Got it? This is your bromobenzene. So this is an electrophile and the electrophile is being replaced. Okay, so this is the total bromination and this is your bromination generation of electrophile, brominium ion. So in this reaction, in the bromination, who is the electrophile? Brominium ion, Br plus. Similarly, you have chlorination. In the chlorination, benzene is reacted with the chlorine in the presence of FeCl3, AlCl3, or many things, many electrophilic accept carriers are used. They are all Lewis acid. You can use FeCl3, AlCl3, BF3, BCl3. Okay, many electron carriers can be used. So Cl2 react with FeCl3 gives rise chloronium ion. This Cl plus is going to be electrophile in this reaction. So in the NEET examination, you will be asked which of the following is an electrophile, like that. So you are going to get a chlorobenzene. ठीक है. Now iodobenzene इतना साफ नहीं है, iodobenzene थोड़ा सा प्रॉब्लम है. आयोडीनेशन, ये जो रिएक्शन है ना आयोडीनेशन, दिस इज ए रिवर्सिबल रिएक्शन बेटा. ये रिएक्शन आगे बढ़ने का आयोडीन इज यूज्ड अलोंग विथ HNO3. दिस इज ए वेरी इंपॉर्टेंट. दिस इज ए वेरी इंपॉर्टेंट पॉइंट. सो आपका स्टेटमेंट 1, स्टेटमेंट 2, assertion and reasoning type, those statements are important and it is clearly mentioned in the NCERT textbook also. You need to read every point. When iodination takes place, benzene is treated with iodine along with an oxidizing agent like HNO3 or HiO3 can be used. Why HNO3 or HiO2 are used here? These are the reason. So it is a HI is a reducing agent. अब पहले देखो, if the product is formed H plus and I minus, so it forms an HI, which is a reducing agent. So in the presence of sunlight and absence of halogen carriers, AlCl3, BF3 or benzene adds 3 molecules of chlorine to form benzene hexachloride. Okay, so that in the presence of light, this is the reaction. Here this point in iodination, oxidizing agent like HNO3 and HiO3 is used to oxidize HI. which is a reducing reagent. So actually this reaction is a reversible reaction. So ये रिएक्शन आगे बढ़ने के लिए एक ऑक्सीडाइजिंग एजेंट इस्तेमाल करना जरूरी है, क्योंकि HI निकालने के लिए, क्योंकि HI इज द रिड्यूसिंग एजेंट. सो ये मारने के लिए आप ऑक्सीडाइजिंग एजेंट इस्तेमाल कर रहे हैं, पर दैट्स वेरी 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 इंपॉर्टेंट. वन मोर नोट हियर, गैमाक्सेन इज फॉर्म्ड, बेंजीन हेक्साक्लोराइड. ओके, ये चींटी के लिए इस्तेमाल करना. सो इट इज एन एंट किलर, इट इज यूज्ड फॉर एंट किलर. घर में भी इस्तेमाल करते हैं, गैमाक्सेन बोलते हैं ना. इट इज एंट किलर, गैमाक्सेन, राइट? यस. Ishita, you only talking. What about the other students, beta? Children, other children? Yes. This is an addition reaction. In the presence of sunlight, it is an addition reaction, but not substitution reaction, because it is taking place in the presence of sunlight. So I want to say here one thing. When you talk about the benzene, when you treat with the chlorine in the presence of FeCl3, when you talk with chlorine in the presence of sunlight, अरे थोड़ा हीट भी करना चाहता हूँ, so in this case chlorobenzene is formed. But here that is BHC, benzene hexachloride. इसका molecular formula आता है C6H6Cl6. so इसका फनी नाम है क्या? 666 compounds. 666 compound. This is an ant killer. Okay. Okay. आगे बढ़ना. नाइट्रेशन. ये नाइट्रेशन में benzene when treated with HNO3 and H2SO4, mixture of concentrated HNO3 and H2SO4 is called nitration mixture. This is what you call as nitration mixture, where HNO3 is going to take, in the simple version I'll give you, HNO3 nitrogen, double bond O and OH, है ना. In the presence of H2SO4, this is going to be H2O, so that you are going to get NO2 plus. This is called nitronium ion. This is what you call nitronium ion is an electrophile. This is called electrophile. So this electrophile is going to attack with benzene to give rise nitrobenzene. So nitrobenzene is a precursor for any perfume industries. So it has a pleasant sweet smell. Hi Piyush. Okay. Piyush, when did you come? You were there in the class, no response. Okay. So nitrobenzene is used in perfume industries. Any perfume, we all use deodorants, we all use perfumes, so that nitrobenzene and the derivatives of nitrobenzene are used here. So no spamming, no spamming. Aryan, very good. Under previous classes you are not there, why? Okay. Next one, sulfonation. In this sulfonation, when benzene is treated with concentrated sulfonic acid, or you can use fuming sulfonic acid, fuming sulfuric acid. In this fuming sulfuric acid, you can use H2SO4 plus SO3, or you can say H2S2O7. in that active electrophile is going to be sulfur trioxide only. Okay. Okay, no spamming, Piyush. Okay, join now. Okay, right. So here sulfuric acid is protonated, so that you are going to get again hydronium sulfate ion, and the electrophile, active electrophile is going to be the sulfur trioxide. In this, you see, my dear students, here this is the hydrogen, this is the hydrogen present on the benzene. Now what happened? Carefully you see, sulfur double bond O, this is your sulfur trioxide. Because of the electronegativity difference between these two, positive charge of the sulfur act as an electrophilic center, so that this pi electron is going to attack there. This pi electron is going to attack there. So you are going to get a benzene sulfonic acid like this. Got it? So what is the active electrophile in the sulfonation of benzene? That is sulfur trioxide. That is sulfur trioxide. Fine, beta. Now let's talk about, so I was discussing something with this slide only. Sulfonation of benzene is a reversible reaction. If you take benzene sulfonic acid and it is heated with a dilute acidic solution, the sulfonic acid is going to be removed and you are going to get a pure benzene again. Okay, this is probably a reverse reaction. So sulfonation takes place in a reverse way. Mind it, it's very important. It is given in the NCERT textbook as well. Okay, so introduction of alkyl and acyl groups in the presence of catalyst. I was saying what are the Lewis acids that can be used in the electrophilic substitution reactions. Okay, probably you can use it for halogenation, you can use it for Friedel-Crafts acylation, Friedel-Crafts alkylation. इसके लिए आप AlCl3 इस्तेमाल कर सकते हैं, FeCl3, SbCl3. Okay, protonating agents like HF, H2SO4, H3PO4, these are all known as, when you use any one of these, you can expect a Friedel-Crafts reaction with benzene. So this Friedel-Crafts reaction is of two types. One is Friedel-Crafts alkylation, another one is Friedel-Crafts acylation. In the Friedel-Crafts alkylation, my dear students, जो alkyl group है ना, जो alkyl group है benzene को substitute करते हैं ना, so this is what you call it as Friedel-Crafts alkylation. आपका जैसे benzene, when methyl chloride, this is a methyl chloride in the presence of AlCl3, you are going to get methyl benzene, you can say toluene. So HCl is formed. यहाँ पर एक्टिव इलेक्ट्रोफाइल एक कार्बोकैटायन होगा. कैसे? So this is RCl, alkyl chloride, right? So when in the presence of AlCl3, AlCl3 is a Lewis acid. So Lewis acid क्या करता है? इशिता Lewis acid क्या करते हैं? Electron pair accept करते हैं. Okay, so that electron pairs present on the chlorine is going to be accepted by benzene. No, this is aluminum, क्योंकि aluminum पर vacant d orbital है. So जो electron pair chlorine का पास है ना, aluminum vacant d orbital तरीके जाना है ना. So that this bond is AlCl3 and this Cl मिला के आपका AlCl4 बनेगा. So that Ar plus a कार्बोकैटायन फॉर्म होता है. जब कार्बोकैटायन फॉर्म होते हैं ना, रीअरेंजमेंट करने का संभावना भी होगा. So you have to check the rearrangement thing, and that electrophile carbocation, alkyl carbonium ion is, or carbocation is active electrophile. My dear students, any reaction, what is the electrophile you need to identify. Okay, now this is about Friedel-Crafts alkylation, and talking about Friedel-Crafts acylation, many reactions are there for alkylation. So the above reaction can be achieved with an alcohol with HF or dilute H2SO4, an alkene with HF or dilute H2SO4. Let me tell you how it can be. Okay, so product कैसे है, like that questions. So you all look at this CH2 HF, H plus and F minus, no, H plus and F minus. So that CH2 double bond CH2 in the presence of H plus, this is going to give you H plus, so that it will give you CH3 and CH2 plus. This alkyl carbocation is going to attack with benzene now, and it is going to give you CH2 and CH3. Okay, ethyl benzene, you get it. I don't want to show you the mechanism this part because you know it. Understand? Anju's kitchen. Who is that? CT Marla? Ishita. Right. Who is this Anju's kitchen? Anju's kitchen. Nice name. Understand. Very good. Nice. Now, whenever carbocation is there, what could be the fate of carbocation? Carbocation can undergo rearrangement, my dear students. So, let's see. Acylation. Again, I will come back to the alkylation, right? So, in the acylation, so benzene, when it is treated with acyl chloride, you are going to get acyl benzene. So, an example here, what happened? Benzene is treated with CH3, C double bond O, Cl. So, the product you are going to see CH3 acetyl chloride. This is called acetyl chloride. The lone pair of electron present on the chlorine, when it is treated with AlCl3, it is going to give you, so it is going to give you CH3. You can see the bond is going to be broken here, right? Here. So that CH3, C double bond O plus, this is called acylinium ion. This acylinium ion is the electrophile. If this electrophile attacks the, you are going to get acetophenone. Right? So, the name acyl benzene is called acetophenone, right? Why? Aryan, no spamming please. Aryan, please, no spamming please. Not good, because we are doing the best from Infinity Learn by the team of eminent lecturers, and we are delivering a great content, and we are nurturing a student's career, right? So, this is a sacred thing and a best we are doing. Okay? So, you please don't spam. Okay? Right. So, we all have to work together for the betterment of your result, betterment of the society. Okay? No spamming, no Google Meets, no come here and there and join. That is not correct. Okay? No spamming please. If you spam again, I am going to remove you. Right? Mind it. Thank you very much. Usually our classes are so nice, so interactive, right? And we never had kind of remove the student, delete the student kind of things. Okay? Thank you. So, acyl chloride, halogen carrier with AlCl3 gives acylinium ion. You can also use anhydride, acid chlorides you can use. This is your acid chloride. and this is acid anhydride. What not, many things can be used. Acylenium ion, yes, acylenium ion is highly stable due to resonance. So, there is no rearrangement when Friedel-Crafts acylation, but there can be a rearrangement if you see the Friedel-Crafts alkylation, my dear students. Okay? Yes. Okay. Anyways, Soumya, I want to say something. Soumya, want to say something? Fine. So, in this case, we already discussed very important points. Everybody knows about these 5 reactions of benzene, like halogenation, nitration, sulfonation, Friedel-Crafts alkylation, Friedel-Crafts acylation. But there are certain things you need to know about this. So, the first point, arylic and vinylic halides cannot be used in Friedel-Crafts reaction. Why? Because if this is removed as AlCl4, this should form a carbocation. This is a vinyl carbocation. Vinyl carbocation is highly unstable, therefore it is not probably formed, right? So, next point. So, my dear students, please focus on the class, right? Now, so in substituted benzenes, if you say NO2, mean to say a nitrobenzene, this is what you call it as nitrobenzene, and cyanobenzene, this is your cyanobenzene, and this is your benzene carboxylic acid or benzoic acid. Okay, if it is acetophenone, okay, or CCl3 benzene or benzene sulfonic acid. So, these are the compounds do not participate in Friedel-Crafts reaction because they are highly ring deactivating groups, they are highly withdrawing groups, so that they pull the electron from the benzene out, so that electrophile cannot go into it. So, they are highly deactivating groups. So, which of the following do not participate in Friedel-Crafts reaction? A, B, C, D options will be given. You have to pick whether this option is there or not in NEET examination, my dear students. Are you getting or not? Komal Kaushik, right? No other discussions, only subject discussions you have to make it, right? Come on. Now, let's talk about और एक चीज है, मैं एक बोलना चाहता हूं आपका, aniline also do not participate, is very important. This is aniline do not participate in Friedel-Crafts alkylation, Friedel-Crafts acylation. Aniline do not involve in Friedel-Crafts reaction. Why? Can anybody tell me? Excuse me. So, Friedel-Crafts reaction. Can anybody tell me reason why? The reason आते quite important है. Aniline में जो lone pair of electron है, so aniline is basic. It react with Lewis acid. We use Lewis acids, na? AlCl3, BF3, these are all Lewis acid, but this is basic, na? So, these are the compound do not participate in Friedel-Crafts reaction. The reason is they are highly deactivating, highly electron withdrawing. But aniline also do not participate in Friedel-Crafts reaction. The reason is blue color. So, statement 1, statement 2 type of question, you check it last 4-5 years how many questions are there from the NEET examination. If you see in the NEET examination paper, total क्वेश्चंस मैक्सिमम ऑफ थियरी एंड लॉजिकल एंड सिंपल ओनली, न्यूमेरिकल बहुत कम से कम होगा, 10 के अंदर है, 50 क्वेश्चन से 10 के अंदर न्यूमेरिकल आता है, 40 बाकी 40 क्वेश्चन जो है ना लॉजिक के हिसाब से आता है, स्टेटमेंट के हिसाब से आता है, असर्शन रीजनिंग के हिसाब से आता है ना. ओके फाइन. So you need to prepare yourself to crack the examination, not like binding over the book, right? So reading 18 hours, no, 26 hours in a day out of 24 hours. So you are thinking in like that. You simply study 8 to 10 hours in a day along with the classes. ये काफी है बस. ओके अब जो करने चाहता हो अच्छा तरफ अभ्यास करो. ठीक है बेटा. चलो नाउ in Friedel-Crafts alkylation most stable carbocation form alkyl halide or alkene determine the final product. Here यहां पर जो है, so here यहां पर जो है anything can give the product like this. You can see, yeah, this is CH3, CH2, CH2, Cl in the presence of AlCl3. So the lone pair of electrons present on AlCl3, so it is going to take care of it and a primary carbocation फॉर्म हो चुका. सो आपका मिलेगा जो CH3, CH2, CH2, ये प्राइमरी कार्बोकैटायन बन गया. जो प्राइमरी कार्बोकैटायन इज लेस स्टेबल, देयरफॉर एक हाइड्रोजन यहां से रीअरेंज करके आपका सेकेंडरी कार्बोकैटायन बनाना है बेटा. सो दैट सेकेंडरी कार्बोकैटायन बनाना है CH3, CH प्लस एंड CH3. ठीक है. एंड वो कार्बोकैटायन बेंजीन से रिएक्ट होने के बाद आपको असली प्रोडक्ट ये है. इसका नाम क्या? जल्दी बोलना इशिता, इसका नाम क्या? ये असली प्रोडक्ट है. सो आइसोप्रोपाइल बेंजीन, इशिता दिस इज आइसोप्रोपाइल बेंजीन, ये इसी का है. आइसोप्रोपाइल बेंजीन, दिस इज हाइड्राइड शिफ्ट. वेरी गुड अंजुष, वेरी गुड. दिस इज हाइड्राइड शिफ्ट, 1 to हाइड्राइड शिफ्ट. अच्छा बोलने के लिए एप्रिशिएटेड. सो इसका असली और एक असली नाम क्या इशिता? आइसोप्रोपाइल बेंजीन का और एक दूसरा नाम भी है क्यूमीन. कल बोलना ना, कल बोला ना. हाँ right. These are the good points about Friedel-Crafts reaction my dear students. और एक चीज है इंट्रामोलिकुलर Friedel-Crafts है, अच्छा बात है. इंट्रामोलिकुलर Friedel-Crafts reaction, you just see alkanoic acid 1 2 3 4. So actually numbering should be given here 1 according to IUPAC, 2 3 4 if you give the numbering according to IUPAC. So 4-phenyl butanoic acid, when it is heated with HF, what happens? It is going to form H plus. Okay, so it is going to form acylinium ion here, protonated, and it is going to form. So this is going to attack here to form alpha tetralone. Alpha tetralone. Similarly, you can check this. You are going to see the formation of a carbocation here, so that it attacks here. This attacks here. So actually when it forms a cyclic ring na, always ख्याल में रखो 6-membered ring or 5-membered ring are generally stable. 5-membered ring or 6-membered ring is generally stable. Are you getting or not? So this is in depth of the Friedel-Crafts reaction. जनरली नीट में इतना डेप्थ रहना तो अच्छा होगा, लेकिन फिलहाल कुछ क्वेश्चन पूछा है नहीं. ओके, वी आर टेकिंग एट द एंड हाईएस्ट लेवल ऑफ द सब्जेक्ट टू यू गाइस. माय डियर स्टूडेंट्स, दीज सेशंस आर एब्सोल्युटली फ्री. वी आर गिविंग फॉर द बेटर सोसाइटी, राइट? So you please honor these sessions and you please attend the sessions regularly, and if you are not in a position to attend the sessions regularly, you at least watch the recordings also. Who is that strange? Okay, you have the sessions also, replay, you can read, you can watch the replay, fine, and you can go ahead with that. If you have any doubts, you can comment. Okay, so Komal, right, fine. So let's talk about direct influence of monosubstituted benzene. We are coming to the end of the session. Direct influence of monosubstituted benzene. So you have various functional groups, dear students. You have ortho and para directors, you have meta directors. So these are the two subcategories of the substituents if already present on the benzene. So when you have these list of groups, strongly activating groups, NH2, NHR, NR2, OH and O minus, this is O minus, okay, and moderately activating, weakly activating, okay, and weakly deactivating. This is a different one, this is a different one, exceptional one, right? Aryan, I said don't spam in the class. So in the meta director, they are moderately deactivating and strongly deactivating. Whenever these groups comes into the benzene, so further electrophilic substitution reaction never takes place. So sir, how do I know a group is activating, group is deactivating? Whenever group is activating, further electrophilic aromatic substitution reaction gives your ortho and para positions, and if whenever deactivating groups are there, the groups are going to give incoming electrophile at meta position. Now my question is, sir, how do I know? Now you can see, so activating, let us say A is activating group, let us say D is deactivating group. Okay, if already activating group is there, if electrophile is added, the product is going to be ortho substituted and para substituted. Please don't spam in the class. Okay, and deactivating group is there. If electrophile is there, you are going to get meta directing groups. Understand? So how do I know a group is activating or deactivating? So any group, my dear students, look at this. If a group is there, so it has a lone pair of electron. This lone pair of electron is going to show positive mesomeric effect. This positive mesomeric effect is ring activating. This is already discussed in the general organic chemistry, mesomeric effect. Okay, para will be more stable. Of course, sometimes ortho can be more stable. So Anjus, you just comment in this session so that I am going to write total explanation for your question, right? You can read it later. Now, if you want to say here group is there, if this group, let us say D, if this D is linked with B, electronegativity of B is greater than D, therefore what happened, this electron is going to be going away from the benzene, so it is called as negative mesomeric effect. So in this negative mesomeric effect, the product is going to be ring deactivating. So जब रिंग एक्टिवेटिंग हो रहे हैं, सो ऑर्थो एंड पैरा प्रोडक्ट देना है, जब डीएक्टिवेटिंग हो रहे हैं मेटा प्रोडक्ट देना है. आर यू गेटिंग और नॉट? क्लियर? फाइन, very good, nice, great. Now this is classify each substituent as activating and deactivating. Now this is the structure. Don't look at the answer. Answer ready made de diya main. Okay, so don't look at this. Whenever you have the lone pair is coming onto the benzene, positive mesomeric effect. Okay, but the thing is here, it is strong negative inductive effect. Halogens have strong negative inductive effect, so it is deactivating. Halogens का बिल्कुल अलग behavior है. Okay, of course they are deactivating, but ortho and para director ख्याल में रखो. Ortho and para director. Okay, leave it. Now NO2, it is negative mesomeric effect, deactivating. CF3 strong minus I effect, so it is deactivating. So it is strong माइनस आई इफेक्ट, इट इज डीएक्टिवेटिंग. ख्याल में रखो बेटा, अच्छा एग्जांपल्स आपको दे रहा हूं. सो एक्टिवेटिंग, क्योंकि हाइपर कॉन्जुगेशन का वजह से it is activating, and here it is lone pair of electron, so it is going to be activating. The lone pair of electron, whenever you find a lone pair of electron, it is activating ortho and para directors. But if you see here, it is going away like this, so it is negative mesomeric effect, it is going to be deactivating. Any doubts here? Anju, okay, Komal, Ishita, right? Fine. Fine. Any doubt? That's good. That's good. Now, rate of reaction of toluene is faster than benzene because it is activating. It is activating. So that if it is brominated, you are going to get ortho bromo and para bromo. Anjun, it said it is a major. Why? Because ये दोनों का बीच में कुछ भी ना कुछ आपका repulsion होता है. So it is a little less stable. Here repulsions बिल्कुल नहीं है. So it is going to be more stable. Fine, clear. That's good. Now, rate of reaction of nitrobenzene is less than benzene. Why? Because it is having minus M effect. So it is deactivating. जब deactivation होगा, मेटा एक ही प्रोडक्ट होते हैं, बहुत less yielding में होना चाहिए. When you talk about chlorine, this is positive mesomeric effect and strong minus I effect. Strong minus I effect के वजह से strongly deactivating. But the thing is here, it is positive mesomeric effect, it is ortho and a para director. So of course it could be a steric hindrance, so you can claim it as a steric hindrance. Okay. Now if you take a structure, there are two benzene rings with C double bond O NH. FF player, hi, hello, you came last. So what happens in this case? If you undergo nitration, na, carefully you observe, this is let us say a bond is like this, you know, this is a negative mesomeric effect, whereas this lone pair of electron is going in the benzene, okay, so positive mesomeric effect. So that positive mesomeric effect वजह से ring B is going to be activated. If this ring B is activated, you are going to get a major product like this. Like this questions are getting in the NEET examination, my dear students. ज़्यादा से ज़्यादा ये ऐसे questions आने का ज़्यादा संभावना है. Understand? Clear? Fine. Fine. Okay. My dear students, in today's class we discuss, you tell me if two substituent, mono substituted benzene is a disubstituted benzene. Actually disubstituted benzene का NEET में इतना important नहीं है, लेकिन I just want to give you one example. If this is a substituent, it is ortho and para. So it is ortho and it is para. It is going to be a meta. ये दोनों का a common point is there, so you are going to get the products like this. If two substituents direct at the same positions, the electrophile, you can get electrophilic substitution, either one directed or other directed, doesn't matter, right? If you find a structure like this, CH3NO2, this methyl group asks here and here, right? Whereas nitro group is going to ask its meta position here. So, but this is ring activating, so this is going to decide the actual product that can be formed. One is deactivating, another one is activating. You have to take the product according to the ring activating group का वजह से इसका हिसाब से देना पड़ता है. Understand? Now, if the two substituents direct in different positions, electrophile follows the orientation of activated ring. That's what I given already, right? So, if this is the case, what is the answer? We are coming to the end of the session. You just give me, Anju, I want to know the answer for this question. I want to know the answer for this question. फटाफट, जल्दी. अरे बेटा, ये वाला देखो. This is negative mesomeric effect. Don't touch. And this is positive mesomeric effect. So you have to go with this. So if you go with this, no, ortho and para. इसका वजह से ये पैरा ये ज्यादा इंपॉर्टेंट है अंजू. It is, you only said ना para is more stable, then why don't you follow that? Option C सही होगा, ऑप्शन सी सही होगा. समझ में रहे क्या? ऑप्शन बी भी होना संभावना है लेकिन माइनर होगा. दिस इज मेजर होगा. समझे बेटा? इशिता फाइन, अंजू फाइन, कोमल फाइन. Right. Today we discussed total benzene and its derivative. Some more questions are there. In there some more questions. Okay, 1 minute, keep. Okay. At last some more questions are there. You can get these notes and you can discuss these questions, and you just write your doubt in the comment box also. Today night or tomorrow morning I am going to answer those questions, right? So we had a discussion about total benzene, structure of benzene, aromatic, non-aromatic, anti-aromatic and their relations and their conditions, and the preparation of benzene, electrophilic aromatic substitution reactions, mechanism and their conditions we discussed. So halogenation, nitration, sulfonation, Friedel-Crafts, alkylation, Friedel-Crafts acylation, and substituted benzene and their directive influences, ring activation and ring deactivation, everything we did it. Okay sir, questions milega chapter ke? Definitely, thank you very much. Definitely you are going to get it. And we have that telegram channel, right Anju? You can join in that. सारा के सारा आपका ये notes आपका PDF form में मिलेगा. Okay, thank you very much for today's session. Great to see, good gathering. And एक बार like मारो, share and subscribe the sessions. Thank you all. God bless you.